Okay, so on page 313, it talks about 10 randomly selected automobiles. So that is a sample size. Were stopped, and the tread depth of the right front tire was measured. The mean, so X bar, was 0.32 inch. And the standard deviation was 0.08 inches. Since these values are coming from that sample of 10 vehicles, then all you have is a sample standard deviation and a sample mean. Because you don't have a population standard deviation, and because your sample size is less than 30, we're required to do a t-interval, not a z-interval. We're required to use a t sub alpha over 2, not a z sub alpha over 2. So if we were going to do this using the formula, okay, and it continues to say, find the 95% confidence interval of the mean depth. Assume that the variable is approximately normally distributed. Well, forget that last statement. If they did not say, assume that the variable is approximately normally distributed, we would want to do this using a t-interval. And so, using your page 684 table of t-scores, you would choose a column based on your level of confidence. So we need the 95% column, which is this column right here, and we need to calculate our degrees of freedom to choose the correct row. So the correct row, which would be degrees of freedom, which is n minus 1, is just 1 less than 10. So that's 9. So going back to your page 684, your chart of t-scores, you go down to your 9th row, you go across the 9th row, until you end up in the 95% column, and your t sub alpha over 2 is 2.262. Again, that's 2.262. 2.262. The formula that we need to use is going to have x bar plus or minus your t sub alpha over 2 times your sample standard deviation divided by the square root of n. So your population mean should be between 0.32 minus 2.262 times your sample standard deviation of 0.08 divided by the square root of n. This is the square root of 10. On the flip side, on the right side, you've got 0.32 plus 2.262 times your sample standard deviation of 0.08 divided by your square root of n, which is the square root of 10. If we use the formula and type this into our calculator, we have the following. We're going to round the lower limit to the same place value as our x bar. So that's the nearest hundredth. And so my calculator has 0.262, so I'm going to round it down to 0.26. Doing the same calculation, only changing the minus to a plus. I'm going to have 0.377, so round that up to 0.38. The formula produces this interval. If we were to check to see if the t-interval feature in our calculator gets the same thing, you do the following. On your calculator, using a TI-83 or a TI-84, you're going to press Stat, left arrow. This is your tests column. You're going to go down until you see a t-interval. Why a t-interval? It's because we don't have the population standard deviation and our sample size is less than 30. Now, we have statistics that describe a sample. We do not have access to the actual data. So make sure that your stats is highlighted by highlighting it, pressing enter, then going down. Type in the given x bar as 0.32. Type in the given sample standard deviation as 0.08. Type in the given sample size, which is 10. The level of confidence is 95%. Write that as a decimal, so it's 0.95. When you press calculate, your limits are provided in the parentheses, separated by a comma, and you'll notice that you got the same values, 0.262, which rounds down to 0.26, and 0.377, which rounds up to 0.38. So the t-interval agrees with the formula.